In the freezing winter of 1941, on the vast plains of the Soviet Union, something extraordinary was about to change the course of World War II. German soldiers, accustomed to their lightning victories across Europe, were about to face an adversary that would challenge everything they knew about armored warfare. This was not just another tank. It was a machine that combined radical simplicity with revolutionary innovation, and when German engineers finally managed to capture an intact specimen and open it up, what they found left them absolutely astonished. The story we're going to tell today is not just about metal and engineering. It's about how necessity can breed genius, how design philosophy can overcome technical sophistication, and how a single military vehicle managed to completely redefine the rules of modern armored combat. This is the story of the T-34, the tank that challenged the Wehrmacht and forced an entire industrial nation to rethink its strategies from scratch. Before we dive into this fascinating journey through military history and engineering, I'd like to ask you to subscribe to the channel and leave in the comments the time you're watching this video. Your participation helps bring this content to more people passionate about history. To truly understand the shock that the T-34 caused the Germans, we need to go back a few years and understand the military and technological context of the time. By the late 1930s, the doctrine of armored warfare was in full evolution. The Germans had developed their theories of blitzkrieg lightning war, which relied heavily on fast tanks working in coordination with motorized infantry and air support. German tanks of the time, especially the Panzer III and Panzer IV, were considered the best in the world. They had a respectable combination of armor, firepower, and mobility. The Soviet Union, in turn, had its own tradition in tank design. During the 1930s, the Soviets produced an impressive variety of armored vehicles, from light tankettes to heavy tanks with multiple turrets. They closely observed the lessons of the Spanish Civil War and border conflicts with Japan in Mongolia. It was from these experiences, especially the battles of Kok and Gol in 1939, that Soviet designers drew crucial conclusions about what a modern tank really needed to be. The man behind the T-34 was Mikhail Koshkin, a brilliant engineer who worked at the Kharkov locomotive factory, which had been converted to tank production. Koshkin was not just a technician. He was a visionary who understood that the next major conflict would require tanks radically different from those that existed. He rejected the conventional wisdom of the time and began working on a completely new design, originally designated as the A-32. What Koshkin proposed was revolutionary in multiple aspects. First, he insisted on sloped armor. This was not a completely new idea, but it had never been implemented so radically in a medium-sized tank. Sloped armor had a simple but profound mathematical advantage. A projectile hitting a sloped plate had to penetrate much more material than the actual thickness of the plate. A 40mm plate sloped at 60 degrees offered protection equivalent to 80 millimeters of vertical armor. In addition, the slope dramatically increased the chance of ricochets, causing projectiles to simply slide off the tank's surface without penetrating. Second, Koshkin chose a diesel engine. At the time, most tanks used gasoline engines. The choice of diesel was not obvious. Diesel engines were generally heavier and less powerful for the same displacement. But Koshkin saw beyond these immediate limitations. Diesel was much less flammable than gasoline, a crucial factor when you consider that tanks are priority targets filled with ammunition. Diesel was also more efficient in terms of consumption, which meant greater operational range. And in the Soviet Union, where diesel was more abundant than high-octane gasoline, there were significant logistical advantages. Third, and perhaps most controversial at the time, Koshkin designed the T-34 with a 76mm gun. This was a significantly larger caliber than the 37 or 50mm guns that equipped most medium tanks of the era. Critics argued that the larger gun would make the tank heavier and more complex. But Koshkin was right to anticipate that enemy tank armor would increase, and they would need superior firepower to deal with future threats. The Christie suspension, a technology that the Soviet Union had licensed from American inventor Walter Christie, was adapted and perfected for the T-34. This suspension allowed the tank to maintain high speeds even on irregular terrain, something crucial in the vast Russian steppes where paved roads were rare. The T-34's large wheels, combined with wide tracks, also gave it excellent mobility in mud and snow, terrain that would immobilize Western tanks with narrower tracks. But perhaps the most important aspect of the T-34's design, and something the Germans would only fully understand later, was its manufacturing philosophy. Koshkin designed the T-34 for mass production. Each component was made to be as simple as possible, with wide tolerances that allowed rapid fabrication even in factories with unskilled workers. The turrets were cast in a single piece, a process that was faster than welding multiple plates. The hull used large armor plates welded at simple angles, without the complex curves and intricate joints that characterized German tanks. When the prototype was ready in 1939, Koshkin was so confident in his design that he organized a dramatic demonstration. He personally drove 2 prototypes on a journey of more than 2,000 kilometers, from Kharkov to Moscow, then to military testing facilities and back to Kharkov. This journey, carried out mainly off-road, in the middle of winter, demonstrated the reliability and robustness of the design. Unfortunately, Koshkin contracted pneumonia during this journey and never fully recovered, passing away in September 1940. He never saw his tank in combat, but his legacy was assured. Series production of the T-34 began in 1940, but in limited numbers. When Germany launched Operation Barbarossa in June 1941, there were only about 1,000 T-34s in service, scattered among various units. The vast majority of the Soviet armored force consisted of older, obsolete tanks. Moreover, many T-34s were lost in the chaotic first weeks of the invasion, not due to technical inferiority, but due to disorganization, lack of adequate training, communication problems, and the overwhelming speed of the German advance. But even in these early encounters, reports began to reach German commanders about a new Soviet tank that was different from anything they had faced. German tank officers reported with frustration that their 37mm guns simply bounced off the sloped armor of the T-34. Stuka pilots described how this Soviet tank was surprisingly fast and difficult to hit. Infantry commanders reported great concern among troops when T-34s appeared, as standard anti-tank weapons were ineffective. General Heinz Guderian, perhaps the most famous panzer commander of the Wehrmacht, wrote in his memoirs about the shock of encountering the T-34. He described how, in October 1941 near Mtsensk, his units had their first serious confrontation with T-34 formations. German losses were unexpectedly high. For the first time, the panzers were not invincible. Guderian urgently requested that specialists be sent to the front to examine this new captured tank. And that's how the central event of our story happened. In the autumn of 1941, the Germans finally managed to capture a relatively intact T-34. The tank was transported to testing facilities in Germany, where a team of high-ranking engineers was assembled to dismantle and analyze it completely. Among these engineers were representatives from major German tank manufacturers, such as Daimler-Benz, MAN, Henschel, and Porsche. There were also military engineers, metallurgists, weapons specialists, and technical intelligence officers. When they began to open the T-34, the first reaction was surprise at the simplicity of the design. The Germans, accustomed to the precision and complexity of their own tanks, expected to find something equally sophisticated. Instead, they found something that seemed almost primitive at first glance. The welds were crude in places, the internal finishes were Spartan. There was little acoustic insulation or comfort for the crew. A German engineer supposedly commented that it looked more like an agricultural tractor than a military tank. But as the analysis progressed, admiration began to replace disdain. The first major revelation came when examining the armor. German metallurgists discovered that Soviet steel had a specific composition that optimized hardness and impact resistance. More importantly, the radical slope of the armor, which initially seemed like a mere design trick, proved to be ingeniously effective. Ballistic tests confirmed that the T-34 had frontal protection equivalent to much heavier tanks. A Panzer III, with its 50mm vertical armor, was significantly more vulnerable than a T-34 with its 45mm of sloped armor. When examining the engine, German engineers found the V2, a 12-cylinder V-shaped diesel engine that produced 500 horsepower. What impressed them was not just the power, but the robustness of the design. The engine was surprisingly tolerant of adverse conditions. It could run on diesel of variable quality, withstand extreme temperatures, and had an operational reliability that the Germans did not expect. The cooling system was simple but effective. Cold starting, a challenge in diesel engines, was facilitated by intelligent auxiliary systems, including the possibility of heating the engine with direct fire in extreme conditions. The T-34's transmission was another fascinating aspect. It was a 4-speed transmission plus reverse, relatively simple in concept. The Germans noted that the transmission required considerable force to operate, especially for inexperienced drivers. But they also noted that it was robust and easy to maintain. When something broke, it could be repaired quickly in the field with basic tools. This contrasted with the more sophisticated German transmissions, which required specialized workshops for significant repairs. The armament was particularly impressive. The F-34 76mm gun was a formidable weapon. With adequate armor-piercing projectiles, it could penetrate the frontal armor of any German tank in service at that time, at respectable distances. The gun could also fire high-explosive projectiles very effective against fortified positions and infantry. The Germans realized with alarm that their own Panzer IIIs and IVs were outgunned in firepower. But there were problems too, and the German engineers catalogued them meticulously. The internal ergonomics of the T-34 were problematic. The turret was very cramped for 2 men, the commander and the gunner, especially considering that the commander also had to load the gun. This work overload on the commander drastically reduced the tactical effectiveness of the tank. The Germans, with their 5-man tanks and 3-man turrets, had a significant organizational advantage in combat. The T-34's visibility was poor. The hatches and periscopes were inadequate, especially with the hatch closed. The commander had difficulty maintaining situational awareness, a critical problem in combat. German tanks, with their commander cupolas and superior optics, had a clear advantage in detecting and engaging targets first. The lack of radios in many early series T-34s was another serious problem that the Germans noted. Tactical coordination at platoon and company level was virtually impossible without radio communications. German tanks, all equipped with radios, could execute complex coordinated maneuvers, flanking movements, and fire concentrations that were impossible for the Soviets. Variable manufacturing quality was also evident. Some components showed excellent manufacturing, while others were clearly rushed. Tool marks were irregular, welds varied in quality, and there were signs of component substitution and improvisation during assembly. This reflected the reality of Soviet production under wartime conditions, where speed was more important than perfection. But here is the real secret that the German engineers discovered, and it took weeks of analysis to truly understand. The T-34 was not superior because it had the best technology in each individual component. It was superior because it optimized the right balance of characteristics for real warfare. Protection, mobility, and firepower were in perfect harmony. More importantly, the tank was designed from the beginning for mass production and maintenance under field conditions. The Germans realized they were looking at a fundamentally different design philosophy. Their own tanks were precision machines, built with tight tolerances and specialized components. This made them more comfortable, more accurate, perhaps even more effective in individual combat. But it also made them expensive, slow to produce, and difficult to maintain. The T-34, with all its pragmatic simplicity, could be produced in numbers that Germany could not match. An analysis report from the Engineering Commission, preserved in German military archives, expresses this perception remarkably. It notes that the T-34 represents a new philosophy of mechanized warfare, where quantity and operational availability are as important as individual technical quality. The report urgently recommends that Germany develop a tank that can incorporate the lessons of the T-34, especially the sloped armor, the larger caliber gun, and the simplicity of manufacturing. This analysis led directly to the development of the Panther, which many historians consider the best medium tank of World War II. The Panther incorporated dramatically sloped frontal armor, a high-performance 75mm gun, and a design more optimized for production than previous German tanks. It was essentially a German response to the T-34, an admission that the Soviets had discovered something fundamental about tank design. But the Panther arrived late, in mid-1943, and was never produced in sufficient numbers to change the course of the war. Meanwhile, T-34 production continued to grow exponentially. From about 3,000 produced in 1941, production jumped to more than 12,000 in 1942, and continued to increase. Entire factories were evacuated to the Urals and Siberia when the Germans advanced, and quickly resumed production in their new locations. The simplicity of the T-34 allowed minimally trained workers, including women who replaced men sent to the front, to manufacture it. Components could be produced in converted civilian factories with relatively basic equipment. The welding, though not pretty, was functional and quick to execute. Diesel engines could be manufactured using techniques already mastered by the Soviet tractor industry. As the war progressed, the T-34 continued to evolve. The most important version was the T-34 WWII, introduced in 1944. This variant had a larger turret with 3 men, relieving the commander's overload. The gun was increased to 85 mm, allowing effective engagement even of German Tigers and Panthers at reasonable distances. Visibility was improved, and all tanks now came with radios. Still, it maintained the basic philosophy of simplicity and mass producibility. The Germans tried to counterattack with their own heavy tanks, the Tiger and King Tiger, formidable machines with almost impenetrable armor and devastating guns. But these were expensive, complex, and produced in relatively small numbers. For every Tiger, the Soviets could produce 10 T-34s. In combat, an individual Tiger was superior to any T-34, but it rarely faced just one T-34. Soviet tactics evolved to use numerical superiority, flanking and overwhelming German positions through sheer mass of tanks. The mobility of the T-34 was also crucial in the Great Soviet offensives from 1943 onward. At the Battle of Kursk, the largest tank battle in history, thousands of T-34s faced the best the Wehrmacht could offer. Although Soviet losses were high, they could replace their losses while the Germans could not. After Kursk, the strategic initiative on the Eastern Front definitively passed to the Soviets. In the great offensives of 1944 and 45, the T-34 demonstrated its superiority in mobile warfare. Soviet armored formations, led by brilliant commanders like Rotmistrov and Katakov, executed deep advances that tore through German lines. The T-34 could advance more than 100 kilometers in a day when necessary, surpassing even theoretically faster German tanks in operational mobility, simply because it broke down less and could be repaired more quickly in the field. The operational reliability of the T-34 was a critical factor that German intelligence reports continually underestimated. While German tanks often spent more time in maintenance than in operation, especially the heavier models, the T-34 maintained impressive availability rates. Its robust suspension rarely failed, its reliable diesel engine continued running under conditions that would immobilize gasoline engines, and its wide tracks rarely came off. Logistics also favored the T-34. A diesel engine consumes less fuel than an equivalent gasoline engine. This meant that T-34 formations had greater operational range and required fewer vulnerable supply trucks. In a war where logistics often determined what was tactically possible, this was an enormous advantage. Soviet armored columns could advance farther and faster before needing to stop for refueling. When the war reached German territory in 1945, T-34s rolled through the streets of Berlin, tangible symbols of Soviet victory. More than 57,000 T-34s and their variants were produced during the war, making it the second most produced tank in history, losing only to the American Sherman. But while the Sherman depended on numerical superiority and air support to win, the T-34 could face the best German tanks in more equal conditions. The impact of the T-34 extended far beyond World War II. After the war, it continued in production and was exported to dozens of countries. It saw combat in the Korean War, where it surprised UN forces who did not expect to face such capable tanks. It fought in conflicts in the Middle East, Africa, Asia, and Latin America. Even in recent conflicts, decades after its introduction, T-34s occasionally appear in combat, testimony to their extraordinary durability. The design influenced generations of subsequent Soviet and Russian tanks. The T-54, which became the most produced tank in history with more than 100,000 units, was clearly a descendant of the T-34, sharing the same philosophy of sloped armor, robust simplicity, and mass producibility. This lineage continues to modern Russian tanks, which still prioritize low profiles, sloped armor, and relatively simple designs. In the West, the T-34 forced a fundamental reassessment of tank design. The British and Americans, who had focused on lighter and more mobile tanks, realized they needed heavier armor and bigger guns. The American Pershing and British Centurion, introduced at the end of the war, reflected lessons learned partly from the analysis of captured T-34s. Sloped armor became standard in virtually all modern tanks. The story of the T-34 is also a story about how war drives technological innovation. Facing an existential threat, Soviet engineers created something truly revolutionary. They did not have the luxury of perfection, so they focused on what was essential. They could not compete in sophistication, so they competed in simplicity. They could not match German quality, so they exceeded in quantity. And in the end, these choices proved to be the right ones. There are also profound lessons here about design philosophy and engineering. The T-34 demonstrates that the optimal solution is not necessarily the most technologically advanced. Sometimes it's the one that best adapts to real constraints and requirements. The German engineers, with all their expertise, initially did not understand this. They saw the imperfections of the T-34 but missed the genius of the overall concept. Only when forced into systematic analysis did the true innovation of the design reveal itself. Mikhail Koshkin, who died without seeing his tank in combat, had understood something fundamental. He realized that a tank is not just a collection of technical components. It is a system that must function in real war conditions, be produced in real factories with real workers, be maintained by mechanics under adverse conditions, and be operated by crews who may have limited training. Optimizing for these practical realities, even at the cost of technical sophistication, was the key. The courage of Soviet engineers and workers who evacuated entire factories, moving them thousands of kilometers east while the Germans advanced, also deserves recognition. They dismantled complete production lines, loaded machinery onto trains, and reinstalled them in improvised locations in the Urals, often working outdoors in freezing temperatures. Within weeks, these evacuated factories were producing T-34s again, an extraordinary industrial feat that contributed decisively to the final outcome. T-34 crews also deserve remembrance. They operated an uncomfortable, noisy machine with limited visibility and challenging ergonomics. The interior was cramped, hot in summer and freezing in winter. The lack of internal suspension meant that every bump in the road was transmitted directly to the crew. The noise of the diesel engine and tracks was intense. Still, these men and women, yes, there were women in Soviet tank crews, demonstrated extraordinary bravery. Stories of individual heroism abound. There are accounts of T-34 commanders who, even in extreme situations, demonstrated extraordinary courage. Of gunners who continued fulfilling their mission even under critical conditions. Of drivers who drove damaged tanks back through enemy lines to save their crews. Of mechanics who worked under danger to repair immobilized tanks. This human spirit, combined with the robust machine they operated, proved to be unbeatable. The story of the T-34 reminds us that technology, however important, is never determinant by itself. It must be combined with appropriate tactical doctrine, adequate training, competent leadership, and the determination of those who operate it. The Soviets took time to develop tactics that maximized the strengths of the T-34 while minimizing its weaknesses. The early years of the war saw T-34s used in frontal attacks that did not fully exploit their advantages. But as experience accumulated and new commanders emerged, tactical effectiveness improved dramatically. The Great Patriotic War, as the Russians call World War II, was won with blood, sacrifice, and determination. But it was also won with steel, diesel, and ingenuity. The T-34 was the physical embodiment of this combination. It was a machine that reflected the society that created it, with all its strengths and weaknesses, its improvisations and its unwavering determination to survive no matter the cost. Today, preserved T-34s stand on pedestals in museums and memorials around the world. In every capital they liberated, on every battlefield where they fought, there are monuments. In Russia, the T-34 is more than a historic military vehicle. It is a national symbol of victory in the most devastating war the country has ever faced. A war that cost more than 27 million Soviet lives but resulted in the end of World War II in Europe. Veterans who served in T-34s, the few who still live, speak of their tanks with a mixture of pragmatism and affection. They do not romanticize the experience. They remember the fear, the discomfort, the constant danger. But they also remember the confidence they felt in their machine, knowing it would carry them through any terrain, that its engine would rarely fail, that its armor would protect them against most threats, and that its gun could destroy any enemy. Engineering is often seen as a technical discipline, governed by mathematics and physics. But the story of the T-34 shows that great engineering also requires vision, courage to challenge conventions, and deep understanding of the context in which technology will be used. Koshkin and his team did not create the most technologically advanced tank possible. They created the right tank for that historical moment, those specific circumstances, that particular war. The German engineers who opened that captured T-34 in 1941 were looking for technological secrets. What they found was a lesson in design philosophy that their own engineering traditions made difficult to accept. Perfection, they reluctantly concluded, was the enemy of good enough. Sophistication had its place, but not at the cost of producibility and reliability. The optimal was the enemy of the functional. This lesson remains relevant today. In a world of increasingly complex technology, there is value in remembering that well-executed simplicity can surpass poorly optimized complexity. That the context of use is as important as technical capability. That production sustainability matters as much as maximum performance. That reliability under adverse conditions is worth more than impressive specifications under ideal conditions. The T-34 was a product of its time and place, impossible to separate from the historical circumstances that created it. The desperation of the Soviet Union facing invasion, the urgency of producing weapons en masse with limited resources, the need for equipment that could function in extreme climates with minimal maintenance, all of this shaped what the tank became. But the underlying principles, the design wisdom embodied in its sloped armor plates and robust diesel engine, transcend that specific context. In the decades since World War II, military analysts and historians have endlessly debated which was the best tank of the war. Passionate arguments are made for the German Panther, the American Sherman, the British Churchill. Each had its strengths. But if we consider historical impact, numbers produced, longevity of service, influence on subsequent designs, and contribution to military victory, the T-34 has an incomparable claim to the title. More fundamentally, the T-34 changed how we think about armored warfare. It established the main battle tank model that all nations would follow. Sloped armor, medium to large caliber gun, balanced mobility, diesel engine, relatively simple design, all of this became standard. Every modern tank owes something to the T-34, whether explicitly acknowledging the influence or independently converging to similar solutions. The story also reminds us of the importance of listening to visionary engineers. Koshkin had to fight against bureaucrats and conservative military officers who doubted his radical ideas. Only his determination, dramatically demonstrated in that 2,000-kilometer test journey in the harsh winter, convinced the skeptics. How many other potential innovations have been stifled by lack of such conviction or opportunity to prove their worth? There is also a tragic irony in the story. The Germans, with their proud tradition of precision engineering, were surpassed by an approach they initially disdained as crude. Their response, the Panther, incorporated lessons from the T-34 but never completely abandoned the complexity that made German tanks so difficult to mass-produce. Even learning from the adversary, they could not fully adopt the philosophy that made that adversary so successful. Finally, the story of the T-34 is inseparable from the people. Not just Koshkin and the engineers, but the metallurgists who developed special steels, the factory workers who welded thousands of hulls, the train drivers who evacuated equipment under extreme conditions, the mechanics who kept tanks running under impossible conditions, and above all, the crews who took them into battle knowing many would not return. In war memorials throughout the former Soviet Union, T-34s stand on pedestals, often painted in dark green or white winter camouflage. Plaques list battles, dates, units. But each tank represents tens of thousands of individual stories. Each scratch in the armor, each mark witnesses to moments of great courage and sacrifice. These war machines are also important monuments and reminders. As we reflect on this remarkable story, we are reminded that innovation often comes from unexpected places and takes forms that defy expectations. The T-34 did not look revolutionary at casual glance. It was just another tank, cruder than many. But in those simple sloped lines, in that reliable diesel engine, in that powerful gun, was a revolution in how wars would be fought. The final lesson of the T-34 is about adaptation and pragmatism. Facing extraordinary challenges, Soviet engineers did not seek the perfect solution. They sought the solution that would work, that could be built with available resources, operated by available people in time to make a difference. They understood that in war, as in many aspects of life, the available now surpasses the perfect later. When those German engineers finished their analysis of the captured T-34 and wrote their reports, they had discovered something deeper than technical specifications. They had discovered that they had underestimated their adversary, not just militarily but intellectually. The Soviet Union, often despised as technologically backward, had produced something that forced even the mighty German industry to rethink its fundamental assumptions. This story of human ingenuity, of how necessity breeds innovation, of how determination and vision can transform metal and mechanisms into decisive solutions, remains relevant. The T-34 was more than a tank. It was an idea made of steel, a philosophy expressed in armor and gun, a testament to what humans can create when challenged to the extreme. And in the end, perhaps that is what those German engineers really discovered when they opened that T-34 and found the real secret. It was not in the components or the metal, but in the vision and determination of the people who created it. May this story inspire us to always seek pragmatic and effective solutions to our challenges, to never underestimate human capacity to innovate under pressure, and to remember that greatness often resides not in complexity, but in well-executed simplicity. And may we, in our own fields and challenges, find the same courage and vision that Mikhail Koshkin demonstrated when he drew that sloped and revolutionary silhouette that would change history. May the Lord God always grant us the wisdom to see beyond the obvious and the courage to pursue our convictions when we know we are on the right path.